Ah, welcome. We are but 2 days away from our vector quiz, and I thought it might be helpful if I did a few review problems in this video and talked about how to solve problems and maybe even do a homework problem. So let's see how this is going to go. Okay, I told you that there would be problems like this, where you have 20 degrees north of west, and I want you to go ahead and give me the degrees in C, W. If you don't remember, CCW stands for counterclockwise, starting here and moving in a counterclockwise manner around the unit circle. So if we have 20 degrees north of west, you always go the second direction first and the first direction second, north of west. So I'm going to go west, and then I'm going to go north, and I'm going to go down. And I'm going to say this is 20 degrees. So it is 20 degrees above the 180. It is 20 degrees above the 180. So that means it's 20 degrees. If you think about this in terms of CCW, okay, this is 90, and it doesn't quite reach 180. It's 20 degrees less than 180. So 180 minus 20, this is 160 degrees CCW. That is all you need to do. If you can visualize what the triangle is, and you're either going to add or subtract it to one of the four main lines. Okay, what if the exact same thing, but instead of 20 degrees north of west, I have 20 degrees south of west? So, okay, still going west first, west, and then south, and then 20 degrees. So I hope we can see that because it's CCW, all right, we hit the 90, and in this case, we're going to hit the 180, but then we're not at the angle. We have to go an additional 20 degrees. An additional 20 degrees. So that means that this is going to be 200 degrees CCW. 180 plus 20. Okay, what about 20 degrees west of north? Okay, so we're the same general thing. We're kind of mixing it up. But this time, remember, you're going to go north and then you're going to go west. You always do the second direction first. So I'm going to go north, I'm going to go west, and there's 20 degrees. So if I see that, all right, from CCW, okay, I hit 90, and then, oh, I hit another 20 degrees to get here. 90 plus 20, that's 110 degrees CCW. What about 20 degrees east of north? East of north. Okay, so we're going to go north. I'm going to go east, and I'm going to go 20 degrees. My triangle's terrible, but you get the idea. So we're at 0, and we don't even get to 90. We're going to be 20 degrees behind 90, or 90 minus 20. That's just going to be 70 degrees CCW. But what if you have something like this? 20 degrees south of east. So you're going to go east, then you're going to go south, and then make this the 20 degrees, okay? So this is 20 degrees behind 360. Wait, Bizzuto, I thought that was 0. Well, it starts off at 0. 0, and you hit 90. You hit 180. You hit 270. And you keep going, but you don't quite hit 360. You hit 20 degrees less than 360 based off this drawing. So this is going to be 340 degrees CCW. Nice. Okay, well, what if I have a degree CCW and I want to turn it into a direction? I know let's use a different color. So here's a really simple way. 100 falls between 90 and 180. Okay? God, those were straight lines. That's awesome. 100 is 10 more than 90. 10 more than 90. Look at what I'm doing. I was at 90, and I have to add whatever degree, this is the degree sign, I have to add whatever degree to equal this. So 90 plus 10 is 100, just like we were doing before, okay? So we hit the 90, 10 more degrees hits 100. 90 plus 10 is 100. So how do I do that? Oh, look at the way the triangle's drawn. I go north, and then I go west. So if I go north and then I go west, I'm going to take the angle (100 degrees CCW is 10 degrees west of north). Okay, 200 degrees. 200 degrees is between 180 and 270. 200 degrees is 20 more than 180. Wait a minute, Bizzuto. Could I say it's 70 less than 270? You could. And technically, you would make the same triangle either way. It really doesn't matter. I think it's easy just to say it's 20 more, but if you want to go ahead and say it's 70 less than 270, be my guest. How did I know it was 20 more than 180? 180 plus 20 is 200. That's how I knew. So you hit 180 and you go an additional 20 degrees to get to 200. Okay, so look at my triangle. Well, that's 20 degrees south of west. Nice. And if you thought that it would be easier to just do 70 degrees, I know this should be the same hypotenuse, I'm sorry, fine. There you go. If you thought it should be 70 degrees, much better, less than 270, look at this triangle. Look at this triangle. This would be 70 degrees west of south. And either way, they are the same triangle. They are complementary angles, and complementary angles are the same when you switch the directions. What if you had 300 CCW? Okay, well, I know that 300 is going to fall between 270 and 360. I'm just going to keep it simple. 270 plus what is 300? 30. Look at that triangle. Look at how it's drawn. That's 30 degrees east of south. Awesome. Okay, what if I have something like this? We haven't talked about the really small degrees. If I have 15 degrees CCW, 15 degrees, all in quadrant 1. 15 degrees north of east. The quadrant 1 stuff is pretty basic. In quadrant 1, 15 degrees north of east is whatever's in quadrant 1, whatever is the CCW, is going to be the degrees in north of east. Okay, this is the good stuff right here. A riverboat is on the west side of a 160 meter wide north-south flowing river. Okay, so what is that? What is that? Can we visualize that? The river is flowing from the north to the south. It's 160 meters wide. So that is a horizontal distance. The river is flowing south at 3 meters per second. The boat rows east at 4 meters per second. So what we're saying is that when the boat goes in the water, the boat is moving east 4 meters per second. This is where the boat starts. I want to know. So it wants to go east, but the water's going to push it down. So it's actually going to go somewhere like this. I want to know what the total displacement of the boat is once it crosses the river. So what that means is, if you stood here and you stood here where it lands on the other side, and we agreed that the current's going to push it down, and if you held a tape measure taut across the river, what would the length of that tape measure be? Well, to solve that, I need to make a little chart. Of horizontal and vertical quantities. Okay, dx, vx, dy, vy, and time. Remember, time transcends the columns. So let's label what we know. We know that the horizontal distance is 160 meters. We know that the horizontal speed, velocity, is plus 4 meters per second because he's flowing east. He's rowing east. We know that the water is flowing south 3 meters per second. Okay. So what I can do is I know the equation. The distance equals speed times time, in this case velocity times time. This is the equation that I'm going to be plugging in and solving, okay? I can use it all with horizontal quantities, I can use it all with vertical quantities. I'm going to use this with horizontal quantities to get the time. So the goal is to find the time. If you can find when the boat stops moving, that time applies to both directions. So we know it's going to stop moving once it crosses the river. So we need to figure out the time that it takes to cross the river. 160 equals 4t. Divide both sides by 4. So it is in the water for 40 seconds, which means it is moving vertically for 40 seconds, because 40 seconds is the total time of moving. Every second it's in the water, it's going to go right 4 and down 3. That's what this is saying. So to get the dy, I'm just going to do the vy times the time, or the negative 3 times the 40, or the negative 120. So what we've learned is that this boat has traveled horizontally 160, that was given, and vertically it's gone negative 120, or 120 down. So those are the two displacements, the horizontal and vertical displacement. So when I want to know what the total displacement is, I'm going to have to use the Pythagorean theorem of the two legs of the triangle. And when I do 160 squared plus negative 120 squared, remembering that if you ever put negatives in a square, they need to be in parentheses. And when I square root that jump, I get 200 meters is the displacement. I did pick those numbers so that they wouldn't be all decimally right now, but you know how I feel about decimals. Now, in this situation, so sorry, before I go to the next question, look back, think about what we did. Think about, we had velocities and we had displacements, and we cared about the total displacement, and that is always going to be the sum of the vectors. Okay. What angle will the boat need to aim so that it moves only horizontally, assuming that it can row at 4 meters per second? So we'll still have the same boat, okay? So it can only row at 4 meters per second. The river is still flowing down 3 meters per second, okay? So what we're saying is the hypotenuse of the triangle that this boat's speed could be is 4. So let's really think about it. The boat speed is 4 meters per second. This boat speed is going to have a horizontal and vertical component. So if we can want it so that it moves only horizontally, we want this vertical component to cancel out with the other vertical component present, which is in this case the river speed. We know that the river is flowing down 3 meters per second. So I want the angle right there that's going to make the vertical component of the boat speed, because when you add, if I break the vectors down, adding them tip to tail, you go right and then you go up. So if I look at this, if this is going to be 3 meters per second vertically, it would cancel the river speed. So remember, when vectors move at an angles, what we're really saying is that you're moving horizontally some speed, and you're moving vertically some speed. You're moving horizontally some speed, you're moving vertically some speed. We know that the total speed is 4. That's what it says. It can only row at 4 meters per second. So that's the total speed. That's the hypotenuse of the triangle. And I know that the vertical leg of the triangle must be 3 so that it can cancel out the 3 from the river speed. Okay? So I could solve for this missing side using the Pythagorean theorem. Don't say it's 1. It's not 1. You know what? Let's solve for that missing side. If I wanted this side, if I wanted this Vx of the riverboat, okay? If I wanted the Vx of the riverboat, it would be Vx squared plus Vy squared, which in this case is going to be 3, equals the final speed squared. Minus 9 from both sides, so that's Vx squared equals 7. So this is the square root of 7, which is 2.64. So it's now moving horizontally 2.64 meters per second, but the vertical speeds cancel out. But I didn't want that. I wanted this angle. So from this angle, I know the opposite and I know the hypotenuse. So I'm going to do inverse sine of that angle of opposite over hypotenuse. When I take the inverse sine of 3/4, I get 48.59 degrees. So what we're saying is, if this boat can row at 4 meters per second, the hypotenuse of its triangle is 4 meters per second, it has to angle its boat 48.5 degrees upstream so that all the vertical vectors cancel and it only moves horizontally. That's what this is saying. Okay, let's look at this one. A riverboat is on the west side of an 80-meter wide north-south flowing river. Okay, so I feel like we've done this before. It's 80 meters wide. The river is flowing south at exactly 2 meters per second. Okay, we've just done this. This is not going to be hard. We just did it. If the boat rows east, so it's on the west side, it's rowing east at 1.5 meters per second, and there are rocks exactly 100 meters downstream. Oh, okay, this is new. We haven't had this before. So what I'm saying is that exactly 100 meters below where the boat starts, there are rocks. So this boat has to cross the river before it hits the rocks. So there are two options. It's either going to make it across the river safely to the other side, or it's going to hit the rocks down below. So we need to think a little holistically about this. Let's make our table. Okay, we've got horizontal and we've got vertical. Okay, my dx is 80. My Vx is 1.5. Okay, and I have a time. I don't know what, I haven't calculated yet, but I can. My dy, I guess it's negative 100. And my Vy is negative 2, because it's going south. And what is its time? Okay. So we have enough information to calculate time for each one. That's interesting. How's that going to work? Well, let's see. Again, I know that d equals vt. So to get time, it's going to be displacement divided by velocity. 80 divided by 1.5 equals 53.3 seconds. Negative 100 divided by negative 2 is 50 seconds. Okay. Bizzuto, I thought you said the times are supposed to be equal. And I certainly did. Then why are they not equal here? Let's think about what it's saying. What it's saying is that it would take 53 seconds to go 80 meters to cross the river horizontally, and it will also take 50 seconds to hit the rocks vertically 100 meters downstream. Which thing is going to happen first? Which thing is going to happen first? It's going to hit the rocks first. Because if you started a stopwatch and it was counting up, obviously 50 seconds comes before 53 seconds. It is going to hit the rocks 3.3 seconds before it would have made it across shore. So it's going to do something like this. It's almost going to make it, but then no, it's not. It's just not going to make it. How much is it going to miss by? How much is it going to miss by? What's the distance that it's going to miss the shore by? Well, let's think about that. It's not actually in the water for 53 seconds because once it hits the rocks, it stops. And I think that's a reasonable assessment and a reasonable assumption that we can make, that once it hits the rocks or once it makes it across the river, it stops moving because now it's crashed. So it is only going to be moving horizontally for 50 seconds. So with this velocity and this time, it actually only travels 75 meters because this velocity times time is 75. So it needed to go 80. So it was just 5 meters away from the shore, but then it hit the rocks. It was just 5 meters away and then it hit the rocks. So sad. Hey, this is a question on your homework. This was a very oddly worded question, so I thought it might be worthwhile for me to kind of go over right now. So you are driving south on a highway at 25 meters per second, approximately 55 miles per hour. That's not relevant, in a snowstorm. When you notice that the snow was coming down vertically, excuse me, when you last stopped, you noticed the snow was coming down vertically, but it is passing the windows of the car, moving at an angle of 30 degrees to the horizontal. Calculate the speed of the snowflakes relative to the car and relative to the ground. I don't even understand what this is. I just don't even get what it's asking. Okay, so let's see if we can visualize this. So you're standing still right here. And then you see the snowflakes and they're just falling straight down. You are now in a car and here is the window That is the window of your car, and you are now noticing the snowflakes are moving at an angle of 30 degrees to the horizon. So let's look at this. This is a triangle. This is why it's confusing. This is an AP question. They did kind of expect you to know that. It says calculate the speed of the snowflakes relative to the car and relative to the ground. Do I know any of the speeds here on this triangle? Well, I know that this is 25 meters per second. I know that because the car is driving 25 meters per second. Bizzuto, but you said south. It said south. I know, so this is all, because it says relative, you could draw it from any perspective that you want. So this is just 30 degrees. The car is, I mean, you if you really wanted, you could rotate this. If it really helped you feel better, you could draw it like this, and you'd still be the same triangle. Okay? Same triangle. So you could rotate it, just so you know. Okay, but I'm going to keep this one because I like this one because it kind of looks like that's what would happen on the window. I know this is 25 meters per second. This would be the Vy of the snowflake, or this would be the Vy of the snowflake, or relative to the ground, because if it was just on the ground, it's only moving vertically. And then it says the speed of the snowflakes relative to the car. Well, that would be that. It is essentially just asking to make a triangle and to solve for the two missing sides. That is all this problem is asking you. So let's do it. Let's use sine and cosine, or tangent. I don't know. Let's solve for v first. Why not? So I have this degree, and I have the adjacent, and I'm looking for the hypotenuse. That's cosine. Don't forget, so sine is opposite over hypotenuse, ka. Cosine is adjacent over hypotenuse, toa. Tangent is opposite over adjacent. So I'm going to use cosine of 30 equals 25 over v. Move v up, move v both sides, and then v cosine 35 equals 25. Divide both sides by cosine 35. (25) divided by cosine 35 is, yes, v is 30. I'm just going to say 30.5. So that is the speed of the snowflakes relative to the car. Now I want Vy. Well, I have this degree and the adjacent. I'm going to use tangent. So tan 30 is opposite over adjacent. So 25 tan 30 is Vy. That's it. 25 tan 30. And that's going to be 14.4 meters per second equals Vy. So this was tough, not because of the math. Honestly, if you understood what this question was asking, the math is actually quite simple. It was tough to recognize how this is even a vector problem. And every time you see something like this, you see a number, you see a degree, you're going to make a triangle. That's really what this is all talking about. And how does that actually make? Can you visualize the situation? And I know this one was a little tough, which is why I decided to go through this one. I think the other two questions are doable, provided that you remember that southwest simply means 45 degrees south. When you say southwest, you mean the exact middle between 180 and 270. So that'd be 45 degrees between them. So 45 degrees south of west or 45 degrees west of south, however you want to think about it. And you guys got this. The homework is due, but you got this. You got this. Nice. Don't forget to like and subscribe.